Hi everyone. Let's solve this problem which was asked in GATE 2022. So this question was asked in analog circuit, right? And this question was based on N-channel MOSFET. Okay, and here you can see that they have given what they have given here. They are asking about VA upon VB. Okay, they are the small signal voltages at node A and node B. Okay. So many of you take a lot of time solving this kind of question. Okay, that's why I brought this question. So this question was asked in a GATE 2022. Okay, so whenever this kind of question is asked, right, so you have to follow my approach, and if you're going to follow my approach, you will get any answer very quickly, right? So let's solve this problem. Okay guys, so this problem was asked in GATE 2022 in electronics and communication paper, and this problem is based on a small signal analysis of a MOSFET amplifier, right? So let's read the question first. Consider the circuit shown with an ideal long channel and channel MOSFET. Okay, enhancement type. Okay, substrate is connected to the source. Okay, the transistor is appropriately biased in the saturation region with VGG and VDD such that it acts as a linear amplifier. So they have told you that this acts as a linear amplifier, and Vi is the small signal AC input. Okay, and and you have to calculate what here V and VB represent the small signal voltages at node A and node B. So before I give you the answer, because this question can be done within 10 seconds, right? Only 10 seconds is needed to solve this kind of question. But before I give you the answer, let me explain you something. Okay. So let's take N channel MOSFET. Okay, the circuit here. So this is going to be the common source. Okay, this is common source amplifier. Okay, just consider the AC small signal Vi is given here, and this is VDD, you can say, and this is RD, and this is a common source amplifier. Why? Because we are taking output here at drain and we are applying input at gate. So this is known as common source amplifier. Okay, see, you can see here there is no resistance in the source terminal. This you have to notice here, right? There is no resistance. That's why I'm saying there is no resistance, right? So what will be the gain, small signal gain for this kind of amplifier? Okay, without drawing any kind of small signal model. Okay, without drawing any kind of small signal equivalent of it, right? So as we know that if we will look the resistance looking from the source terminal, right, so it will be 1 by Gm, right? Always you have to keep this in mind. Okay, in the classroom I always discuss. So this is what so if you will look from the source terminal, okay, it is going to be 1 by Gm always, right? And if you look from here to here, from output to the ground, see, when you will try to find the small signal gain of the amplifier, so you will have to make this DC to the ground. Okay, so if you're looking from here to the ground, so it will be RD, right? So what you can write here is, now the voltage gain is what? V out upon Vi will be equal to what? See, you are applying input at gate and you are taking output at drain, and this is the source. So now you can directly write the gain of this amplifier without drawing any kind of small signal model, right? So you must know these things. The overall gain of any kind of transistor, be it your BJT or the MOSFET, okay, depends upon the ratio of the resistances looking from different terminals. So here you have to put the minus sign here so that you could have the 180-degree phase shift. So if you're looking the resistance from the output to the ground, so it is RD, and if you're looking resistance from the source terminal, so it will be seen as 1 by gm. So you might have studied the overall gain, small signal gain of the common source amplifier is what, minus gmrd, when there is no source resistance present, right? This is without source resistance. Okay, see how quickly I have written. Okay, you don't have to draw any kind of a small signal model because it's a gate examination question, so you must know how to write the gain. Okay, and in fact sometimes I have seen many people give the solution like they give S parameter, I mean they draw S parameter model in case of BJT and they solve question and it becomes very complicated, right? Okay, if the source is degenerated, right, if source is degenerated, source is degenerated, if the source is degenerated, then what will happen? What is the meaning of source degeneration? When the source resistance will be present. So let me draw again the circuit, right? This is common source only, okay, because the you are applying input at gate and taking output at drain, and the common terminal is always what? Common terminal is always the source. So this is going to be your RS now, and this is RD, and this is your VDD, you can say. After all, we will make it ground when we will try to calculate. This is, you can say, VI. Now again what you can do here is you can make this guy ground. Okay, all DC should be make it 0. Okay, all DC should be connected to ground. Yeah. So again this here you have to calculate the output, right? So now tell me what is going to be the output, I mean what is going to be the gain of this transistor. Okay, so gain, the voltage gain I am talking about is specifically, again there will be minus sign, and you know that if you have studied like the gain is basically depends upon the ratio of resistances, right? So if you see resistance from this terminal, okay, source terminal, so it is going to be 1 by gm. Suppose there is no RS, but there is a RS which is in series. So if you see from here, so it is going to be 1 by gm plus RS. Okay, and if you see resistance from output to the ground, so it is RD simply. So you just take the ratio, it is going to be RD upon RS plus 1 by gm. I hope this makes sense. So further you can simplify this, so gm will go up, so it is gm RD upon 1 plus gm RS. I hope it doesn't confuse you, right? It makes the analysis very easy. Okay, you don't have to remember anything, right? So see, you have seen this kind of expression for gain when the source is degenerated. When source is degenerated means there is a source resistance present which makes your gain decrease. Okay, see here the gain has been decreased. Earlier it was gmrd, now it has become gmrd upon 1 plus gmrs. So if you got to see this, you don't go further. Okay, so if you take this gm, okay, in the denominator, so it will become what? RS plus 1 by gm. So this is what the gain of the source degenerated, right? Okay, and it is a common source amplifier with source degeneration, right? Now what they are asking, let's get back. Okay, so they are asking here, they are asking what? They are asking the small signal voltage at VA and small signal voltage at VB, ratio of them, right? Ratio of VA and VB. They are asking ratio of V and VB, and they are the small signal. What is VA? VA you can say is minus, okay, minus, okay, AV times VE, okay, VI, right, V in, and your VB will be what? Your VB will be AV times VI. So this is what? This is for the common source amplifier, because there would be 180-degree phase shift, and in this case, okay, when they are asking about the small signal voltage at the source terminal, right? So you are applying input at gate and you are trying to find the output at source, so it became common drain. Okay, so this gain belongs to common drain, and this belongs to common, okay, with source degeneration, don't forget. So common source amplifier, they are the amplifiers only. That's why we are trying to calculate the gain, right? So within 10 seconds you can answer this kind of question, right? So if there is a common drain is given, okay, so let me calculate the gain for common drain amplifier. Suppose this is VI, sorry, and this is V out, equal to VB in your case. So this is RS, okay. So now what is going to be the output upon input? That is gain. So if you see from this point to the ground, okay, if you see from this point, after all the output terminal is now this has to be common, okay. So there will be after all this is what the common drain amplifier, right? You can make this guy ground, no problem, and RD. Now RD will not come into picture, okay, because after all this is output, okay, and this is input. So what you can do here is common drain amplifier will have like a you can say kind of a voltage buffer as well, because see okay, it is also known as source follower, right? So here you can say that it is output, so it is going to be RS upon, okay, resistance looking from this terminal to the ground is RS, and resistance looking from here is 1 by Gm, and this is in series, so you can say that it is going to be RS plus 1 by Gm. That, I hope that makes sense. So this is the, you can say AV. So from here what you can say, BV will be equal to what? Gm RS upon 1 plus Gm RS. If you see resistance, okay, from this from here to the ground, okay, that is RS, okay, but after all input is connected here, right? So now everything will be depending upon the output terminal only, okay. So that is 1 by Gm plus RS is the total resistance which you have to divide, and looking from this terminal to the ground, that is RS. So this is VB, and my VA will be, in this case, this is VA, okay, that is gonna be VA. Now take the ratio, no problem. Let me go back and tell you here. So now you have to take the ratio, okay. So 1 by Gm RS is common in both the case, okay. So let me write here that VA upon VB will be minus Gm RD upon Gm, because 1 by Gm RS is present in both the gains, right? Whether it is common source amplifier or common drain amplifier. I hope this makes sense. So GM will get cancelled, definitely they will get cancelled, no problem. So you can happily cancel them, right? So your overall answer is going to be RD by RS. And in the question what they have given here is, let me check here what is RD is 4 and RS is 2. Okay. So here you can say RD is 4 K upon 2K. Okay, this is going to be minus 2 and it has no dimension. So this will be the answer for this question. You don't have to draw any kind of equivalent, right? Any kind of equivalent. You must be able to write the gain by inspection. Okay, by inspection. This is what the main motive was, to conduct this session live and to solve question in front of you. I hope this makes sense for everyone. The answer for this question which was asked in gate 2022, okay, so answer is going to be, I hope this makes sense. Okay, so you give me any kind of amplifier, okay, and if you want to calculate gain, I will calculate the gain within 10 seconds only, right, without drawing any small signal model. Why? Because you are restricted to your nodes. Okay, because you know that the gain of the amplifier is what, minus gm rd. That's it, your life is ended here. You don't go further. If you go further, so you can write this as rd upon 1 by gm. What is this? rd upon 1 by gm. This is the resistance looking from output to the ground, and this is the resistance looking from the source terminal. That's it. Okay, so here you can write also a resistance looking from output node to ground, and this seen from source terminal. So I will be bringing more questions like this, which you can solve within 10 seconds, 20 seconds, right? So this was the question from GATE exam, GATE 2022, and answer is -2. So I will bring more questions on analog, and I will show you that you can solve any question within 10 seconds, right? Okay, so you don't have to draw the small signal model, okay, all the time. Thank you so much. Please do watch this session. We will meet the next session.